Yeah, the last talk to sit through before we can head to the after party, so let's do it. Cool. I'm Anton, and today we'll be talking about sidecars, and specifically how mysterious, how undervalued art we can say of injecting sidecars into your Kubernetes workloads. I'm part of the engineering team at Sentry.io. So yeah, if you're looking for a good error tracking solution or application performance monitoring, session replay product, check it out. Cool. So what are we going to cover today? We'll start with maybe like a discussion of what sidecar containers actually are. How can we manage them, manually, automatically? We'll see how easy or difficult it is to do it yourself, and whether there are any tooling like frameworks or libraries that we can use. And also, we'll take a look in the future. Basically, are there any solutions, approaches already that can kind of transport us already to the sidecar-less world, maybe? We'll see. Let's get started. So sidecars. As it turned out, sidecar is a term coming from the world of motorcycles. And basically, yeah, it's this extra compartment that you have next to your motorcycle. You can use it to, to transport another human being or pretty much anything else. And similarly, in Kubernetes, sidecars provide some extra utility to your app, right? More or less. But still, the question is, what are sidecars exactly? So let's talk about pods and containers. For folks who run a single container inside their pod, I would say I'm actually pretty happy for you. And if it works for you, just go for it. For all the others who are not so fortunate, let's keep talking. So inside a pod, as you know, we can have more than one container, but there are different types of containers we can run. So first of all is an init container, right? So init containers are those that run to completion before the regular container starts. And yeah, init containers are used mostly like for initialization, that kind of stuff. Application or regular containers. Those are containers where you run actual like useful workloads, like your application workload, and those normally run in parallel. Finally, we have ephemeral containers. So it's a relatively new feature starting from Kubernetes 1.25. We can run ephemeral containers using, for example, kubectl debug command. And those are normally used for troubleshooting, and especially they're useful when you run distro-less images, right? So images where you don't have any like shells you can kubectl exec into. So from those containers, what are sidecars, right? So let's leave ephemeral ones aside. So they're a bit special because, for example, you cannot define ephemeral containers in your pod spec. And similarly, you cannot just like kubectl edit pod and add ephemeral container. So, so those will be just like left aside. But for example, should we call sidecars all of those, init plus application, or should we only call extra application containers sidecars? Before we answer this question, this is actually a feature I am super excited about. So starting from Kubernetes 1.28, we now have an almost native support for sidecars. It's still in alpha, and it's behind the feature gate, but when enabled, basically you can define a special init container with restart policy set to always. And this will be a a sidecar in this kind of like new definition, basically two things will happen. The first one, after this container starts, along with other init containers, it will be on its own, right? Like we will not wait for termination of this container. And the second part is it will not block the pod shutdown, right? So these are probably two main annoyances people have when we talk about sidecars. And now we seem to have a solution for this. So this is pretty cool. Check out the announcement. And I would say awesome timing because this was released in alpha, I think, less than a month ago. So to stay compatible with this new definition, at least for this talk, let's agree that a sidecar, it will be any init or regular container, excluding the main one, just to kind of reason about the extra utility we add to your app. So basically those. And speaking of utility, sidecars can be used for pretty much anything, right? Logging, observability, security, authentication, you name it. Pretty much, yeah. You can run a sidecar with any extra utility. And to look at an example of a mature product that uses sidecars to deliver this extra utility, we'll take a look at Istio. So Istio is a service mesh solution. And yeah, let's say you have 1, 2, 10, 100 different applications or services, and you want to connect them with each other. The thing is, you do not want to solve all the connectivity challenges for each of them, right? So we want connections to be observable. We want actually the connections to work to begin with. We want to have some kind of traffic management and then add security, maybe load balancing on top. And this is what Istio and other service meshes solve for us. So how do they do it? How does Istio do this, for example? Sidecars. So there they are, basically running next to your application, talking to each other, and also to the control plane. Let's take a look. So an example, simple pod, one container. And now what will Istio do with it, basically? So Istio provides a command line tool that takes your pod manifest and then injects all the necessary configuration, so sidecars, volumes also, which is important, because we can share information between sidecars and the main application, or like between init containers and sidecars mostly. And we get this. Especially check out line 35 to 45. OK, I also cannot read it, and that's the thing. So this is complexity. This is something that we don't want to see, that we don't want to be aware of. And we don't like complexity. We don't like to read through hundreds of lines of YAML. For that reason, Istio provides another approach. Everyone likes one-line changes. I mean, I definitely do. So Istio lets us to do this, right? Just by adding one label, we get the equivalent output with what we did on the previous slide, right? So when this manifest is applied, we'll basically get this. So 3 containers, 1 init container already completed, and 2 running containers, so our main application Nginx and Istio proxy. The question is, how? Why? What kind of magic is that? And yeah, this is where our secret sauce jumps in. So let's talk about Kubernetes admission controllers. When a request, and for us it's most important to consider creation, like create, update, or delete kind of requests. So for any of those requests, processing on the Kubernetes server side happens in stages, right? So the important ones are displayed here. And we are mostly interested in this too, in mutating and validating admission web controllers, not yet webhooks. The thing is, there are a lot of already like built-in admission controllers that's kind of running by default. For example, when you start a pod without a service account defined, there's a mutating admission controller that will add, like, inject a proper service account statement into your pod. Or similarly, when you do not specify like a storage mode for your persistent volume, the default one will be also injected by one of those controllers. But we are, again, like mostly interested in the two special ones. So they are mutating admission webhook controller and validating admission webhook controller. So those are the magical controllers that allow us to delegate, or more like, let's call delegate. Basically, they allow us to send the given request to an external service, to a webhook service. And yeah, thus allowing us to extend the logic with pretty much anything that we want. So if we take a look at what Istio does, Istio defined two mutating, two validating configurations for those controllers. And as we can see here, actually for mutating ones, Istio has 4 webhooks per configuration, because you can specify more than one webhook inside configuration. And just take a look at one of those configurations, like at one of those webhooks. This is one of them. It's the same, like it's a single configuration, just like 2 columns. And it might look like a lot of YAML, but actually we are interested in 3 parts. The first one is the destination service. Excuse me. Actually, it doesn't have to be a service. It can just be like a URL, like an external kind of URL. But in this case, it's a service inside our cluster. And we specify the name, namespace, and like path, like URL, HTTP URL, where requests, for example, pod creation requests, will be sent to. The second part is the request filter. In this case, we only care about pod creation requests. And this is where we specify this. And the third part is object selector condition. We can filter what kind of pods are actually affected or like considered for this kind of webhook configuration. And in this case, we basically say we only care about pods that have this label set to true and another label being absent, does not exist. And yeah, this is basically the magic, right? So if you want now to write your own admission controller, let's summarize. We have to be careful here. If you want to write your webhook, custom admission webhook handler, here's what you have to do. First, we need an HTTP server, right? Like the actual core component that will process the request. The first annoyance is that it should handle TLS. So Kubernetes will force TLS on you, so you'll have to manage certificates, and yeah, there's no way around that. It should naturally be also API compatible, so it should talk Kubernetes, right? So webhook request will be sent in a special format, and you are also expected to reply in a special format. Let's say we want to run it inside the same cluster, right? So we'll need deployment service. We'll also need those YAMLs for webhook configuration. So either mutating or validating or both, if you want more flexibility. Because the idea is that mutating runs first, as you might remember. And then we have schema validation, which is an important also stage. And then validating webhook, it's the one that can basically say yes or no. Right? So mutating can do any kind of changes. Then the schema validation happens, and then validating webhook, basically final check, hey, are we good? Yes, no. And then the request will continue. Honestly, I would still say this is a lot. Like, this is some of those things I do not want to manage myself. So I guess it's time to acknowledge that we need some help. And the help will probably come, hopefully, in the form of some tooling, like libraries or frameworks. I decided to try and write a simple webhook server in Go. And of course, again, like you can do it from scratch, but I would say in Go it's especially annoying because, well, Go is like a native Kubernetes language, so they really care about like all the typing. And I found this library. It's called admission control. And at least it has some helpers that can help you, for example, like deal with marshalling, unmarshalling those requests from and to Kubernetes server. So at least they can manage this part. And also they provide some wrappers, like manifests that you can use as an example, also like a Docker file that you can use to build the image. It hasn't been updated recently, but like I actually had to fork it and add a few fixes to remove some deprecated APIs. Then I tried to do the same thing in Python. And here I got really excited because I found this COP framework. And honestly, I didn't want to look any further. The thing is that COP is a lot more than just a library for writing admission webhook controllers. It's a general framework about all things operators. And it's still actively, well, let's say actively developed. So let's look at an example. In just a few lines of configuration, we initialize the COPF application. And the cool thing is, COPF is really doing a good job with helping you to develop locally. For example, in this case, we actually create an ngrok tunnel. So ngrok is the service that allows you to expose your local service on the web. So what happens is COPF will initialize an ngrok tunnel that will point to your COPF application that you run locally on your machine. And now from inside the Kubernetes cluster, your server, your COPF server, will be reachable. Pretty cool, I think. And the second line basically indicates that, hey, we want to manage all those webhook configurations magically, auto-magically. Now to the handler itself. It's also just like a single Python function. In the decorator, we can specify filters. So again, we only care about pod creation requests and the specific label that will be used as a filter. And then here at the bottom, this is where the magic happens, right? Like this is where we basically inject an init container in our pod. you run this file just like this, and it works. As easy as that. So I was really amazed by how easy things can be, and Kopf, no affiliation, but yeah, I was pretty happy that I found it. But let's say that we still need something simpler, right? Like we don't want to write any Go, Python, or anything else. Maybe a bit of YAML. That would be fine. And let's say, yeah, like, what if the sidecar configuration that you're injecting is actually not that dynamic, right? Maybe it's just like a fixed image, a fixed, command that you want to inject. This is where the generic frameworks for sidecar injection jump in. And if you search on GitHub, you actually find a few of those. I think top 4 should be here. They have their small differences in how they are configured and how, like what kind of feature they support, like plus, minus. But the common feature is that, yeah, they allow us to specify configuration that we want to inject. They are themselves admission controllers, right? So you just need to install it once. And then you can use it for different use cases. So let's take a look at the first one as an example. The idea is the following. The spec of the sidecars we want to inject will be specified in a config map. It will basically be a patch to the pod manifest. And actually, in addition to regular and init containers, we'll be able to also inject volumes and image pool secrets because, yeah, if you specify custom image, you might need secrets to pull it from a private repo. So yes, this is a config map. For example, we want to inject 2 containers, one init, one regular one. And then inside our pod, we basically, in a special annotation, we refer to this config map by name. And that's it. We'll have the same effect. So nginx is running, init container already completed, the second one is also running, and yeah, it just works. By the way, K9S, the thing like the UI, also love it. If you haven't heard or used it, check it out. All right. At this point, we might feel quite powerful. We basically wield the magic of injecting, like modifying manifests on the fly at will without too much effort required from our side. But after this initial euphoria, you might start wondering, are we really at the pinnacle of technology, right? Like, is it the ultimate state of affairs? And when you think a bit more, and yeah, all kinds of things like this will start jumping in your head. So let's say you are doing something that's related to networking connectivity, right? When we're talking sidecars, it would mean that we'll have an additional hop and thus increased latency. If you have a huge number of apps, like services, service, not a good name, apps in your cluster, and if you run a sidecar next to each of them, you might be allocating a lot of resources. And those might be underutilized because, well, not every app gets the same kind of traffic. Rolling out updates, right? Like, you actually need to restart the entire pod to apply some changes to the sidecar. And complexity is actually not going anywhere, right? Like we're kind of sweeping it under the rug, but it's still staying there in the form of admission controllers and webhooks, configurations, and all that. So yeah, this raises the question, is there a life beyond sidecars? Yeah, I don't know what. And we'll take a look at what service mesh solutions have to say about this, because for them, it's an especially sensitive kind of topic. So Cilium project has Cilium service mesh solution. And they claim that we already live in this sidecarless future. It's already here. And the magic sauce for them is eBPF, right? So eBPF is this, yeah, we can call it magical, right? So this magical technology that powers those transparent, powerful things that let us get rid of the sidecars. So basically, their approach is we inject some eBPF, like custom kernel programming, into each host. And this can already handle a lot of features for us. In some cases, like when we deal with HTTP, like when we need some kind of load balancing, like retries, rate limiting for L7 protocols, like HTTP, like DNS, it's okay to fall back to Envoy proxy, which is also running one per node. So no sidecars needed anymore. This is the future we're going into, and all good. Now, Linkerd is another service mesh solution, and they have the opposing opinion. So they claim that we need proxies, like sidecar proxies, and we will need them in the future. So investing too much into eBPF is not very reasonable in this case. And they mentioned things like, yeah, writing eBPF is hard, so the model is kind of limited. You know, like you need special skills to write eBPF programs. And also, sidecars are not that bad. And actually, they have like lots of advantages. For example, with per host proxies, you have larger blast radius. So if something goes wrong, your whole node is somehow affected. It's harder to maintain because, again, like you'll need to drain the entire node just to maybe like update or like roll out changes to your host agent. And also, yeah, security is also an issue because you might be running different apps with different security restrictions profiles on the same node. And like, what if, you know, there's a bug and something bad happens, some traffic gets mixed up. So basically, yes, for Linkerd, sidecarless future is not viable. So they're investing in their sidecar approach. As you see, there's no single answer, right? Like sidecar or not a sidecar. The future will tell. I think for us as users, let's say, like I'm a user in this case, I think it's actually a pretty great time to be in because this kind of competition is what's moving the technology forward. And I guess also it depends on your use cases, of course. So to wrap up, we've covered some tech today. I would say it was at least like for me when I heard about all that, or at least like when I saw it for the first time, it was sufficiently advanced to be indistinguishable from magic. So that's why kind of the magic sort of thread through the presentation. And yeah, I think what a time to be alive. Cool stuff. But I just want to remind you of one very important rule. I think it's especially important in our days of Kubernetes, cloud native abstractions, all sorts of things. Basically, we need the right tool for the job. If you don't need sidecar injection, if you don't need service meshes, it's fine. But if you need something like this, hope this was useful. Thank you.
We're right on schedule. Thank you very much for the talk. So we should switch to the Q&A session, but I don't see any question on this Slido app, so I will just firing up the questions here. Do we have anyone here who has questions in the audience? Raise your hand. We're friends. We're good? Yeah, one.
Would you say the line draw for the use case, the service meshes or eBPF, would reside on your tolerance for latency? Because if you place a sidecar, you're inevitably increasing the latency, right? So.
I would say it really depends on whether latency is a problem for you. I guess in certain cases you would not even notice this kind of latency. So the latency aspect here is okay, for some people it's more sensitive, let's say. So for them it makes sense to run some benchmarks, Linkerd versus Cilium or Istio, for example, because Istio also has now a thing called ambient mesh, right? So also a sidecar-less approach when you run one agent per node and not a sidecar. So I would repeat that every company, every user, every use case should draw their own line, I would say, yeah.
Any other question? Again, raise your hand. We're friends. Nobody will smack you or whatever.
People just want to go to the barbecue. So
yeah, I think they're waiting for the barbecue stuff. No more questions? 3, 2, 1. Well, thanks for coming, and thank you again for your talk.